Statistics is based on probability theory, and therefore it's beneficial to have a good concept of probability when dealing with statistics. We use probability all the time in our everyday lives. For example, what is the probability that my candidate would win the next election? Should I buy this lottery? Will my avocado be ripe? Scientific questions that uses probability might be host-pathogen interactions. What is the probability of getting infected? Animal interactions. What is the probability of individuals meeting? Or survival. What is the probability of a juvenile surviving into adulthood? And of course, many, many more. The definition of a probability is the frequency of which an event of interest occurs. For example, the frequency you get a 6 when you roll a die. And this implies that we are looking at a stochastic process, that is a process that is determined by chance, like the roll of a die. And it also implies that each individual outcome has the probability of the outcome occurring. And what that means is that each time you roll a die, the probability of getting a 6 is 1/6. And if you roll a die 100 times, you will get 6 approximately 1/6 of the times. A probability takes values from 0 to 1. 0 is something that never happens. For example, the probability of getting neither heads or tails on the flip of a coin. That is 0. You will always get one of them. 1 is something that always happens. For example, the probability of getting either heads or tails on the flip of a coin. You are certain to get one of them. And we refer to probability as P or PR or prob. And the probability of an event, for example A, we write as P, the event in parentheses, or PR, or prob, the event in parentheses. And here we also get another reminder of why probability is so essential in statistics. You have already heard about the p-value. And we use the p-value to determine if something is statistically significant or not. And the p-value is a probability. And an event is considered to be unlikely when it occurs with a probability equal to or lower than 5 times out of 100. That is our significance level of 5%. And other common significance levels are 1% or 0.1%. And the definition of a p-value is the probability to get the observed result, or an even more deviating one, given that the null hypothesis is true. And we will come back to this definition many times over the course. In classical probability, the probability is the proportion of favorable outcomes out of the outcomes that are possible. So, some examples. What is the probability that from a deck of cards I would pull a card with hearts? There are 13 hearts in a deck of 52 cards, so the probability is 13 out of 52, which is 1 in 4. Now, what is the probability that you pull a card that is a king? There are 4 kings in a deck of cards of 52. The probability is 4 out of 52, which is 1/13. Now, you could also ask the question, what is the probability to draw a card that is either hearts or king? Now, these events are not mutually exclusive. They can happen at the same time. We have 13 hearts, we have 4 kings, and we have one event where we have both a heart or a king of hearts. This means that the probability to draw either hearts or kings is the probability to draw hearts, 1 in 4, plus the probability to draw a king, 1 in 13, minus the case where they occur at the same time, the heart or king, which is 1 in 52. This is called the addition rule. The probability of event A or event B, or both, is the probability of event A plus the probability of event B minus the probability of event A and B occurring at the same time. If the events A and B are not mutually exclusive, that is, they can occur simultaneously, we write this probability as PAB. If the events A and B are mutually exclusive, that they cannot occur simultaneously, then we don't need this last part of the equation. For example, getting a number 1 or 2 on the roll of a dice. These cannot happen at the same time. So getting a number 1 or 2 is 1/6 plus 1/6, which is 2/6, 1/3. Now to another question. What is the probability of getting the outcome heads when tossing a coin 2 times? Each time you flip a coin, the probability of getting heads is 0.5. And when you flip a coin 2 times, there are 4 possible outcome series. Heads, 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 tails, tails, heads, or tails, tails. The probability of each of these series is of course 1/4. The probability of getting heads, heads is 0.25. That is also 0.5 times 0.5. So the probability of 2 independent events that both occur is the probability of each event multiplied with each other. This is a multiplication rule. Last of all, we will focus on conditional probabilities. This is the probability of an outcome of dependent events that follow each other, and that is their probability multiplied, just as we have learned before. For example, what is the probability of drawing 2 hearts after one another when drawing them without replacement from a deck of cards? First heart is 13 out of 52. The second probability, we only have 12 hearts left in the deck of cards, and we only have 51 cards in total. So the second probability will be 12 in 51. This is the probability of event B, the probability of drawing the second heart, given that A has happened. Given that we already have drawn 1 heart, the probability of drawing another is 12 out of 51.